Unlike the last video that I made on practice test 1, there's already going to be some information here and I'm just going to go through it. So this is what your answer should look like. Here, this right restriction moves it to the right 1, so that means x can't be 1. That also makes a vertical asymptote. This moves it up 6. That also means that the range cannot be 6 because that's your horizontal asymptote. This negative, typically the graphs are in these two little kitty corners, but because that negative, it flips both graphs. Now, if you do this in your calculator, the point should automatically tell you where those two graphs should be. As long as you have your asymptotes, you should do that first. Here, if I plug 0 in for y, you have to first subtract over the 6, and then I multiply by that whole thing on the bottom. I personally like to distribute that in, and then subtract the 6, and then divide by -6, and I get positive 4/3. That needs to be there. If I plug 0 in for x, right here, it would be -2 divided by -1, which is 2, plus 6 is 8. So that's what your graph should look like for the first one. For the second one, here I factored first. So both of these are restrictions. Both of these are points of discontinuity right here. So at -3 and at 1. So these two cancel. Right when it cancels, it creates a hole. So this hole, this -3, whatever cancels right here, this -3 that we know is a restriction, that cancels, that creates a hole. I plug that into my simplified equation. Plug -3, because that's where the hole is, into my simplified equation. I get -1/4. Now, your points of discontinuity, your domain, it's either going to be a hole or the vertical asymptote. Since this one did not cancel, then that creates your vertical asymptote. My horizontal asymptote, I look at before it was factored. So my x over x squared, looking here, that means your m is less than n. So when there's less on top, so this is like x to the first over x squared, your less degree on top, that means your horizontal asymptote is always at 0. Now, because of this, x-intercept is when you plug 0 in for y, but because we can't have 0 for y, we will not have an x-intercept. Because of this dotted line, you have your horizontal asymptote at 0, you have this horizontal asymptote at +1, you have an open circle at that -3, -1/4, and again, your other points you should be able to find on your graphing calculator on your table. If not, you should let me know. Next, here's our original equation. It's saying that this is the parent function. This moves left and right. Remember, that's always opposite. That's your h values. This will, because this is negative, this actually says plus right here. That moves up and down. Whatever this is as shown. So that's a -4. Final answer. Horizontal asymptotes. Because my m and n in this equation, they're equal to each other, then I'm looking at my numbers out in front. So 5 over 10. So 5 over 10 gets simplified to be 1/2. Here, I would actually multiply it out. Here, I would have an x times x, which would be x squared. So now, looking at just my leading coefficient, so I don't have to multiply it all out. You sure can if you want. M is greater than n, meaning that there's a higher degree on top than there is on bottom. So whenever that happens, there's no horizontal asymptote. For question number 6, first, I always state my restrictions. Both x and z are on bottom, so both of those cannot be 0. There's no adding, subtracting. Remember, you can't have things that would be 0 that makes the bottom 0. So then I simplify 42 divided by 36. You can do that in your calculator and turn it back into a fraction, 7/6. When I look at my x's, there's more x's on top. So I'm going to have my x on top. 5 take away 1 is going to give me 4. My z's, there's more on bottom. So I'm going to put my z on bottom. And then 4 take away 2, give me 2. And if you could also do it with the z's right here, that's the same thing as z2 minus 4, which is equal to z to the -2, which is the same thing as 1 over z squared. Either way, z squared should still end up on bottom. The second one, first thing I did is factor. But before I actually simplify this, I said this bottom part, remember this whole thing can't be 0. Because if this is 0, then it would be undefined. So this actually helps me figure out what x can't be. Subtract 3, divide by 2. X can't be equal to -3/2. These two cancel because of this multiplication right here. Wham, bam, thank you, man. I'm left with just the 2. Next. First thing I did here was factor. So I factored a 5 here, and I multiplied across. And I factored a 10 out here. 5 times 10 is 50. I'm left with just the 1x and x plus 1 over x plus 1. Now I can find my restriction. So this x can't be 0. Here, this x can't be negative 1 because that makes it 0. Now when I simplify this, 5 over 50 is the same thing as 10 over, if I want to do this, 10 over 1. This x can be simplified with this x. And because this is multiplying, this x plus 1 can simplify with this x plus 1. So really what I'm left with is just 10. Here for question number 9, first thing I did is factor here. So I've done nothing else, factored. And then I set up my restrictions because y is all by itself, y can't be 0. With division, this first fraction always stays as is. You only flip the second fraction. Dividing by a fraction is multiplying by its reciprocal. Right at this point, now I'm going to have new restrictions. So y cannot be negative 5 here. It can't be positive 2 here. Now I see where I can simplify. So when I'm looking at this, I can simplify my x or my y minus 2 with my y minus 2. I can't simplify here. However, I can simplify y squared over y cubed. Y squared over y cubed would be just 1y left on bottom. 1y left on bottom. So when I multiply across, I'll have my 4 on top, because that's still there, right here. I'll have my y minus 3. I have my y plus 5. Question number 10, first I have to combine them, so I have to add them together. So I have to figure out my least common multiple is. My least common multiple will be x plus 2, x plus 2. So this one actually doesn't change. This first fraction doesn't change because this denominator was not going to change. This second one, though, I need another x plus 2. So I need an x plus 2 over x plus 2. Because I'm not solving anything, I'm trying to make it look the same. Right here, you should always distribute. So in this case, on the left-hand side, I have 2x plus 4. So when I add these together, x plus 2x will give me 3x. Oops, 3x. 2 plus 4 will give me 6. Again, here's my restriction. So just 1x plus 2. I can take out a 3 on both top and bottom. Take out a 3 on both top and bottom. Now, because of that multiplying, you can only simplify when multiplying. Because of this multiplying right here and right here, only 1x plus 2 can be simplified on both top and bottom, leaving me with 3x plus 2. Next one, my common denominator is going to be 2y times y plus 2. So from here to here, I'm missing a y. Since I'm missing a y, I have to multiply by y times y on both top and bottom. Y times y is y squared. Now y times 2y is going to be the same thing that I already have written. Here I'm missing a 2. So now I have to multiply by 2 over 2 because I'm not changing the fraction at all. 2 times 2 is 4. What I am left with here is 2y, y plus 2 on bottom, with y squared minus 4. If you wanted to, you could go plus a negative so that you don't forget that that's a minus 4. Now, y can't be 0 here, y can't be negative 2 here. I can factor this. Y plus 2, y minus 2 over 2y, y plus 2. So now because of this multiplication, these two can cancel out, leaving me with y minus 2 over 2y. Final answer. Complex fractions. First, I have to combine these top two fractions. Notice this bottom fraction is already a fraction, so I don't have to do anything here. My common denominator is xy, so this first one I have to multiply by y over y. So that's going to give me 2y on top, on bottom, xy. From here to here, I'm missing an x. I have to multiply by x over x, which would give me 3x. So this one's adding. So this part has not changed at all, and this bottom equation has not changed at all. But now I can combine these two. So on top, I have my xy on bottom, and then 2y plus 3x. And just like before, this first fraction, the 2y plus 3x over xy, That does not change at all because here you are dividing by a fraction. You multiply by its reciprocal. Whoops. This should have an x on top and -5. So on top, I could multiply across, but this x right here can simplify with this x right here. Nothing else can cancel though. So I'm going to have my 2y plus 3x over -5 because you're multiplying across -5y, sorry. You cannot simplify this y with this y because this term is being added. This has to stay as one big group. Question 13, again, I have to combine the top and the bottom before I can do anything else. On top, or my top, actually on both top and bottom, it's x plus 4. So here I'm going to have x plus 4 over x plus 4 to find my common denominator, giving me 2x plus 8. Here, this 3 does not change because it already has the x plus 4. I'm going to multiply by x plus 4 over x plus 4, which gives me x plus 4 over x plus 4. So this so far has not changed. I'm just looking at my top. So I'm going to have my 2x, and then 8 plus 2 will give me 10. My bottom stays as just one x plus 4. On bottom, my x plus 4 stays the same. X, and then 3 plus 4 give me 7. This top equation, I'm going to factor out a 2 here because I can, and that's my business. I'm going to change this to multiplication. So multiplication of the bottom means you flip your fraction. So right here, these have to all stick together. But because multiplying, I can cancel this with my x2, x plus 4 out, leaving with 2, x plus 5 over x plus 7. Final answer. Question 14, first I have to find my common denominators, which is x plus 2. So this first one I have to multiply and finding my common denominators, x plus 2 and top none. I have to distribute that, which is just going to give me x plus 2. The second one from here to here, I need to multiply by x over x. X times x is x squared. Now I'm just going to be focusing on the left-hand side. So on the left-hand side, I have x squared plus x plus 2 over x, that doesn't have to be in parentheses, x plus 2 is equal to 1. I'm going to move this whole thing over to the other side. I'm going to do that by getting rid of this division. The opposite of division, because a fraction is just division, is going to be multiplying. So I'm going to multiply on this side, and I'm going to multiply same thing on this side. Not finding common denominators like up here. This is us just combining them together. Here I'm moving something over to the other side. So on this side, I'm going to have my x squared plus x plus 2. I'm going to distribute 1 times x is just x. X times x is x squared plus 2x. And now I'm going to solve here. I'm going to subtract my x squared on both sides. And I'm actually going to move this x over to the other side. Subtract x, subtract x. So these x squares cancel, leaving me with just 2 is equal to what I have left here is just x. Now I have to check to make sure that that's part of my domain. X can be equal to 2, x can't be -2, so my answer is x is equal to 2. 15, my common denominator is x plus 2, x minus 1. So here I need to multiply by x minus 1 on both top and bottom. You have to distribute this x to both terms, so x squared minus 1, or minus 1x. Here I'm missing an x plus 2, so x plus 2 on both sides. Just becomes x2 plus 2x. So this bottom does not change. This x plus 2, x minus 1 on top. X squared plus x squared is 2x squared. Negative x plus 2x will give me a plus x is equal to 2. I want to get rid of this division. I don't want that division there, so I'm going to multiply by x plus 2, x minus 1, x plus 2, x minus 1. These two cancel. The nice thing about doing that is that these two cancel. That means I don't have that division anymore. I have 2x squared plus x will be equal to, I'm going to multiply these out. So this will become 2 first. Oh, actually the outside, it doesn't really matter. leaving me with 2 on the outside, x squared plus x minus 2. I have to distribute this 2 to all three terms, so I have 2x squared plus 2x minus 4. Now when I'm solving this, I'm going to subtract my 2x squared. Those two will cancel on both sides, so that's nice. I'm also going to subtract my 2x. Subtract 2x, subtract 2x, leaving me with a negative x is equal to negative 4. Divide by negative 1 on both sides, x will be equal to 4. Wham bam. Oh, thank you, ma'am. Last two. So first thing I did over here is I multiplied both sides by 9. These two 9s cancel, leaving me with just this x minus 6. And then I multiply by the x plus 6 on both sides. You can do this whole step from here to here right away. Some people like to have more visual. Next thing I'm going to do is negative 27. I'm going to multiply this out. So this becomes x squared plus 6x minus 6x minus 36. So negative 27 is equal to x squared minus 36. Since I just have this one x, I'm going to add this 36 over, leaving me with 9. A positive 9 is equal to x squared. So now when I want to get this x squared by itself, I take the square root. So this would give me a positive or negative. The square root of 9 is 3. Positive or negative 3. Make sure that that's in my domain, and it is. So I had both of those answers. X is equal to positive or negative 3. And last but not least, my common denominator here is 6x. So I have to multiply this by 2 over 2, because this right here will give me a 6x. So this gives me 10. Here I have to multiply it by 3x over 3x, because now this gives me a 6x, which will give me a negative 9x. I'm personally going to go like that. On this side, I have to multiply by x over x, which will give me just 1x, because now on bottom, that would give me 6x. 6x. You have to multiply by 6 over 6, so that would give me 30. So again, that would give me the 6x. So on the left-hand side, I have negative 9x plus 10 over 6x. On the right-hand side, I have x plus 30 over 6x. Now, because of this division, I'm going to multiply by 6x on both sides. The thing that's nice about this is because the denominators are the exact same on both sides. So really, I'm just looking at what is on top of both of those fractions. Now I can easily solve this. I'm going to add over 9x, which would give me 10x here. I'm going to subtract over 30, which would give me a negative 20. Divide by 10, divide by 10. Negative 2 will be equal to x. And there you have it. You are so smart, you're going to ace, get an ace in the face. Hey, 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 ace in the face for this test. Thanks for following along. Have a great day.